Hello, in this video, we're going to be talking about how to move around a unit circle, given a starting location, and how many degrees we're going to add or subtract to that location to figure out where our ending point is. You should know the coordinates and the angles in a unit circle, both degrees and radians. That's going to be some other video you can watch if you want to help memorizing that. But right now, this video is going to assume that you at least have access to these values, or you can get them on your own for right now. Real quick thing about clockwise and counterclockwise in a unit circle in terms of moving around. Counterclockwise is always going to be the positive because you notice that those numbers go up, where clockwise will be subtracting because, well, even though those are going from 330 to 315 to 300, notice those numbers are going down. So we're always going to subtract for clockwise, and we're going to add for counterclockwise. So make sure that you circle those and you understand that basic movement around it, because that's going to help us with getting these values. So add for counterclockwise and subtract for clockwise. So let's get into how to do these problems. All right, in these series of problems, we're going to be focusing on giving a starting location and a specific angle movement. So it could be in radians or degrees, and you're going to have to give the ending location both in coordinates and in the angle, which is going to be either a radian or degree or both in some cases. So let's look at this first example. We're going to begin at -0, and rotate clockwise 60 degrees. So in a unit circle, and I'm going to use this at the end to check, but right now, let's talk about where -10 is going to be. So -10 is going to be right over here. So that's my starting location. What angle is that to start with? Well, if you remember, that's going to be 180 degrees. So this is going to be 0, 90. This is going to be 180. So I'm starting with 180. Now I want to go clockwise 60 degrees. So clockwise means to subtract. So we're going to take 180 and we're going to subtract 60. And that's going to give me 120. But then you have to decide, is that number between 0 and 360? It is. So we're ready to figure out where that location is. Well, we know the angle is 120 degrees. Now, 120 degrees is going to be right here. It's 30 more than 90. So on the unit circle, you should know that that coordinate, notice that it's about halfway over here. So it's going to be -1/2 since it's in quadrant 2. It's the x value is negative. And then the y value would be the square root of 3 divided by 2. You have to know those exact values for those coordinates specifically. So 120 degrees is going to be at that location. We also have to give this as a radian. So to convert to a radian, you'll do 120, put that over 180, reduce that fraction, and multiply it by pi. 12 out of 18 is 2/3. So that's going to be 2/3 pi, or 2 pi over 3. So your final location is going to be at -1/2 square root of 3 over 2. That's your coordinate. And your angle is going to be at 120 degrees, which is also 2 pi over 3 radians. Let's make sure that we can check that on our unit circle. For right now, while you're still freshly learning the unit circle, it is good to verify where that is. All of these values that you're going to calculate are going to be one of these that you see down. So when we start at 180 degrees, that's going to be -10. And if I go clockwise 60 degrees, that is going to put me in this direction. And 180 minus 60 is 120. And you can see 2 pi over 3 radians and the coordinate -1/2 square root of 3 over 2. So that does check our answer. Let's look at another example. In this example, we're going to begin at the coordinate -square root of 2 over 2, comma square root of 2 over 2. We're going to rotate counterclockwise, which means to add 555 degrees. So let's think about where we're starting at. Well, it's going to be negative positive, so I know it's going to be in quadrant 2. So notice that they're both the same coordinate. That's going to put you right in the center here. Okay, so that coordinate on the unit circle, draw this out quick. We have to figure out the angle measure because we have to start with the angle since we have to rotate at an angle. So that angle, well, if this is 90 and this is 180, remember these are 45-degree increments halfway. So 90 plus 45 is going to be 135. So that's actually a starting angle at 135 degrees. So we're gonna work with that, and we want to go counterclockwise. So we're gonna add to that. So we start at 135, and then we're gonna add 555 to move around the unit circle. Well, those are gonna add to, let's see, let's put 555 here. It's gonna be 10, 5, 6, 7, 8, 9. That's 690. 690 is not a number in the unit circle. So since we're too big, we're going to have to find a coterminal angle and get a number between 0 and 360. In this case, we're going to have to subtract 360 until we get our desired angle. So minus 360. Well, that's going to put you at, let's see, 690 minus 360. That's going to be 3. 9 minus 6 is 30. And that is a number between 0 and 360. So now we have to figure out where that's going to end up. So if I go to 330 degrees, well, let's start down here. This is 90, 180. This is going to be 270. This is 360. So I know 330 is 30 degrees less than 360. So that's going to be closer to 360 than it is going to be 270. So that coordinate, now notice the x value is a little bit longer here. So that coordinate is going to be the square root of 3 over 2. And then the y value is negative, so it's going to be negative 1/2. Remember, those two go together. So that's going to be my final coordinate. And then we just have to get the radians from there. So your final coordinate is going to be negative square root of 3 over 2, comma negative 1/2. Your angle is going to be 330 degrees. And then let's get the radian. So 330, remember we divide by 180. Throw a pi on top, reduce this fraction. 33 over 180 is 33 over 18. Both of those are divisible by 3. So that's going to be 11 over 6. So 11 pi over 6. I'm doing this without a calculator. Certainly, if you need to check with a calculator and you're allowed to, you are welcome to do that. So those are your three kind of parts on that unit circle. Let's go ahead and check the picture to make sure we're on the right track. So how do I know that I've gone 550 counterclockwise? Well, it's a little hard, but you can certainly figure it out. If I'm going to be starting at 135 and I want to go counterclockwise, let's just start with 360, right? 360 is going to put me right back there. But I have to go an additional how many? Well, 360 plus what is going to get me 555? Well, let's subtract. So 555, so 0 plus 5. Let me pause that here and just use the calculator. So it's actually going to end up being 195. So let me fill that in here and we can kind of see where that additional 195 takes me. So if I go another 195 degrees, well, let's just start with 180. We know 180 is going to put me right on the opposite side. So it's kind of halfway between. But then I have to go another 15 degrees to get to 195. So 180 plus 15 is 195. And that is going to put me at 330 degrees, which coordinates to 11 pi over 6 radians. And the square root of 3 over 2, comma negative 1/2 is your coordinate. So that does line up. In this example, this is going to start at 0, -1. It's going to rotate, but it's going to rotate along a radian. So when you're doing that, my advice for these is to convert to a degree. So I would just multiply by 180 over pi. 4 times 180, see, is going to be 720 divided by 3. I think that's 240 degrees. You can double check my math on that. So we're going to begin at 0, -1. So on the unit circle, 0, -1 is going to be down here. That's going to be, well, this is going to be 0, 90, 180, and 270 degrees. So since 0, -1 starts at, is at 270 degrees, we're going to start there. And we want to go clockwise. Now, clockwise is going to be minus. So we're going to want to subtract 240 degrees from them. Where does that put us? Well, we're at 30 degrees. Now, 30 is already in the unit circle between 0 and 360. We're going to have to convert this back to a radian since it starts with a radian, but since I'm listing the angles in both radians and degrees, we would have done that anyway. So let's figure out where that coordinate is going to be. Well, 30 degrees is going to be closer to 0 than it is 90. So that's going to be, the x value is going to be the square root of 3/2. And the y value is going to be 1/2. Both of them are going to be positive because we're in quadrant 1. So that's my coordinate. Now, as far as the radians go, we can take your 30, again, reduce that out of 180 and put a pi on top. 3 goes into 18 6 times, so it's going to be 1/6. So we say that's going to equal pi over 6. So our final coordinate is going to be the square root of 3/2, comma 1/2, which is 30 degrees, which is pi over 6 radians. We can check our unit circle to verify we're right. And you can see those are going to lie right there. And we can even do the movement around it. So starting at 4 pi over 3, 270 degrees at 0, -1, and rotating 4 pi over 3, which is 240 degrees. You can see 4 pi over 3 is 240, so that's a little cheat sheet there if you needed to, but it's clockwise, so we're going this direction. And that's going to put you right back there. So that verifies where we end up. You should probably try this one on your own. So pause the video and give it a shot. Then you can unpause it and you can check our answer. All right, let's begin. We want to plot the point at 0, 1. 0, 1 is going to fall at the top. 0, 1's right here. That's going to be 90 degrees. And we can also think about that as 7 pi radians, or pi over 2 radians. So if you want to do it in pi, you can. Let's do it that way, since we need to practice that anyway. So we're going to go counterclockwise. And so to go counterclockwise, we're going to add. Okay, add counterclockwise is going in this direction. So we want to take pi over 2, and we want to add 7 pi. So if we convert that, that's going to be multiplied by 2, multiplied by 2, that's going to be 14 pi. That's going to give me, that's 1 pi, so it's going to be 15 pi over 2. Now that's way too big. So we're going to have to subtract 2 pi, subtract 2 pi, subtract 2 pi until we get the angle between 0 and 2 pi. So we can keep doing that in terms of pi. It's minus 2 pi. Really what that is 4 pi over 2. This can be kind of time consuming, but you can see how I do this here. 15 pi over 2. 2 pi is 4 pi over 2. That's going to be 11 pi over 2. Still too big. Remember, we're only trying to get 2 pi here. So the most it could be is 4 pi over 2. So we're going to have to keep going. That's going to give you 7 pi over 2. Too big still, so keep subtracting 4 pi over 2. That's going to give you 3 pi over 2. Three pi over 2 is a number that is between 0 and 2 pi. 3 divided by 2 is 1.5. So that's going to be between 0 and 2 pi. So we are good now. We have our degree, we have our angle in radians. Let's get it as a degree and figure out what that coordinate is. So 3 pi over 2 is going to be 270 degrees. I can verify that with you by multiplying by 180 over pi. 3 times 180 is going to be 540, or you can do 180 divided by 2. That's going to be 90. And 90 times 3 is 270. So that's going to be 270 degrees. And at 270, if you recognize where that should lie, this is going to be 0, 90, 180, and 270. So that coordinate right there is going to be 0, -1. So your final resting point is going to be at 0, -1. That's going to be located at 3 pi over 2, which is 270 degrees. All right, guys, thank you for watching this video. Have a good rest of your day.